Hi everyone, welcome back to my channel. So in today's video we are going to talk about the most requested video from many students, which is Universal Verification Methodology UVM series. Yes, many of you are requesting me about UVM series in my Telegram channel as well as my LinkedIn and Instagram also. Yes, for all those students who are requesting for starting of this UVM series, yes, here I am starting UVM series for all of you. So hope it will be helpful for you. Many of you are complimenting me that my System Verilog series are being helpful to you. Yes, thanks for all your love on those System Verilog series, and hope this UVM series also will be helping you in such a way. And so before going into UVM, if you are new to this video, first you should understand that in order to understand universal verification methodology, you should know Verilog and System Verilog. If you are a beginner who want to enter into design and verification domain, then there are two languages which you should be mastering in. One is Verilog and the second one is System Verilog. So these two are mandatory in order to enter into design and verification domain. Now coming to what is UVM. UVM is not a language, universal verification methodology. From the name itself you can understand that UVM is the standardized approach. Okay, that means it is a methodology in order to verify a complex digital designs. Using System Verilog, we are developing a standardized approach in order to verify a design, which is by with the help of UVM, right? Universal verification methodology. So Universal provides a set of libraries, classes and guidelines which will help the verification engineers to create the reusable, scalable and portable test benches. That means in order to reuse a test bench, in order to have a in order to make the complex test bench into the minimized manner, in order to have a scalable test bench, the UVM was developed with set of libraries, classes and guidelines, right? So this is about universal verification methodology. And if you are someone who doesn't know or understand System Verilog, then you can't understand universal verification methodology, because by using System Verilog approach only, you are developing a System Verilog test. You are developing a test bench in this UVM. So you need to understand one thing before starting to learn universal verification methodology. The first thing is you should understand all the concepts in System Verilog thoroughly. And the second important thing is you need to at least develop a simple basic test bench code in System Verilog in order to understand the universal verification methodology concepts, right? So if you don't know any of these things, then don't worry about that. I have already made a separate playlist for these two things. Like I have made a playlist where I covered all the topics entirely in System Verilog, and the second playlist where I have developed various components. I am explaining various components within System Verilog. Like we have developed a code for generator, we have developed a code for driver, we have developed a code for transaction. So all these things we have developed, and presently I am working on that also. I have already released 3 or 4 videos on how to develop a code for generator, transaction, test bench stuff. So all these things I have already made a separate video on that. You can just check out in the description box where I have mentioned clearly about those two playlist links. Okay, so yes, this is about the System Verilog thing. Now coming to, yes, if you already know and all these things, and if you are learning UVM, yes, you are at the right path. Now coming to universal verification methodology. So this is about a brief introduction on what is universal verification methodology. Hope you got it. So it is not a language, it is a methodology, or it is an approach in order to verify a complex digital designs using System Verilog. So why do we need UVM? Yes, this is the most important question, because as I already told you, by using System Verilog concepts only, we are developing a test bench in universal verification methodology, right? So we are already developing the code. We are already developing a SV test bench environment, right? Then why do we actually separately need UVM if we are having a SV test bench? Yes, this is where the question occurs. So even though we are having SV, why do we are going for UVM? Right. So the most important thing is that you know that in system Verilog we are having various test bench components like agents, monitors, drivers, scoreboard, environment, etc. So in this way you're having lots of components in system Verilog. Right. So, but in system Verilog there is one thing which is missing, that is there is no particular framework or guidelines in SV which helps to design the test bench in a uniform manner across different teams. Why is it? Because you already know that by using system verilog or universal verification methodology, we are verifying complex test benches. That means we are developing the complex designs, and in order to verify that complex design we are developing the system verilog or UVM. Is it or not? So when we are developing a complex digital designs, when we are verifying the complex digital designs, it is not a single team work. Is it or not? Right, we require various teams. When it comes to system verilog, this synchronization among the various teams is missing. Okay, so the that means when we are developing a code in system verilog, that is only limited to one single team. Okay, the synchronization among various teams is missing in system verilog because there is no particular framework or guidelines which should be followed by all the teams in a uniform manner. Okay, in system verilog this guidelines or this framework is missing, which is why we have made a separate TB design in order to have a uniformity among all the teams. Okay, in order to make all the teams to uniformly follow certain rules and regulations, we have prepared a methodology called either UVM. We have made a methodology which is either UVM or OVM. Okay, so basically, just like we are having in HDLs, we are having Verilog and VHDL. Similarly, for this methodologies also, for these rules and regulations, there are again various methodologies like UVM, OVM, etc. Right, but basically since almost everyone opt for Verilog compared to VHDL, similarly most of the people will be opting for UVM. Most of the companies will be opting for UVM compared to that of OVM. Right, so this is the need for UVM. Hope you got an idea on why do we need UVM, right? In order to make all the different teams to have a uniform manner, we are opting for UVM, which is missing in system verilog, which is why we are going for universal verification methodology. That is why we are calling it as universal verification methodology. That means universally every all the teams or all the companies who are opting for verification should be using following this particular methodology in order to develop the test bench, in order to verify the complex digital designs. Right, so this is the need for UVM. Right, so, as I already told you, UVM provides the common framework. Based on SV only, this everything is done. Like based on SV, such like SV supports various. As in SV, we are having various enhanced features like objects, object-oriented programming, constraint randomization, functional coverage, assertion-based verification. If you see this, all these are the enhanced features of SV. Okay, UVM will also be supporting all these features. Right, UVM provides a common framework which is based on system verilog and supports. Okay, UVM will be supporting all the features that are present in system verilog. Also, it defines UVM defines a standard verification architecture. Okay, which if you see in UVM also the same components which are present in SV, those are the components that are present in UVM also, like test environment, agent, driver, monitor, scoreboard. So this is the standard verification architecture that is provided in UVM. Okay, in UVM it will be having certain set of utilities such as configuration databases, okay, factory, messaging services, register abstraction layer. So all these things we will be talking about in the future classes. Don't worry about that. So UVM will be providing all these things apart from the features that are supported by System Verilog. They are certain methodologies. So these are all the guidelines, rules and regulations or methodologies that you will be learning within the UVM, right? Configuration database, about factory settings, which is very important, messaging services, register RAL, register abstraction layer. Okay, so these all are the things which are used in order to simplify the tasks. Okay, in order to simplify the verification task, these are all the things that we will be using, right? By Okay, and then by using UVM, verification engineers can create, as I already told you, in order to create the modular, reusable and configurable test benches, which are easily adapted by various design specifications and verification goals. This UVM was developed, right? And also it will be using, the main purpose of UVM is for reusing. Okay, in order to have a verification reuse across different levels of abstraction, like either it can be either block level abstraction or subsystem level abstraction or system level abstraction also. In order to have a verification reuse among all these layers, UVM was developed. Okay, now coming to what are the advantages of UVM. UVM provides a standard way in which TB can be designed, making it more reusable and more scalable, right? And also the important advantage of UVM is that it provides the phasing mechanism, okay, which helps. That is what from the starting, what is the need of UVM? Provides phasing mechanism which helps synchronizing each component of the TB. Okay, that is what we are talking about. That means if we directly use System Verilog to create the test bench environment, then what happens, as we discussed before, synchronizing the various components in multiple teams will be difficult, which is why we are opting for UVM. That is the main advantage of UVM. How it will be doing, how the synchronization will be happening, because in UVM we are having a concept called phasing mechanism, through which the synchronization happens very easily, right? And then by using TLP ports, okay, the flow of packet between different components will be much easier. Okay, which is one of the other advantage of UVM. The second advantage, like the first advantage, is by using phasing mechanism, the synchronization will be easy among all the components. And then by using TLP ports, the packet flow between different components will be very easily happening. And then other advantage, now coming to UVM factory. Okay, this is one of the main advantage, like UVM factory helps simplify the modifications of the, if you are having any modifications within the components, if you are just registering it in the factory settings, then you can easily simplify it, which is another advantage. Okay, and then UVM separates the TB components with sequence items. There is one more concept called sequence item in UVM, which was introduced in UVM, because you don't see this sequence item concept within the System Verilog. Okay, this was introduced in UVM. So UVM will be separating this TB components with the sequence item. Why is it? Because this sequence item, as we already from the starting itself, we are speaking like reusability purpose, okay, scalability, which are the important properties in UVM. So how does this reusability, where actually we are using this? So basically we are taking a sequence item where we in which we will be using all the packets which need to be used among various components. And then what we'll be doing, we are separating the sequence item from the TB components, so that we can use the sequence item in different test benches. Okay, clear? So this is about the sequence item concept, which is also another advantage in UVM. Okay, and then UVM provides the base class for component, okay, which is the starting point to write components. So for every code that you are writing within UVM, you will be starting with a UVM base class. Okay, once you learn how to what is this UVM base class and how to write a code in UVM base class, you will be understanding everything related to this thing, right? So these are the advantages of UVM. Now coming to what are the disadvantages. So basically there are not many disadvantages. One thing is UVM will be having a high learning curve. That means it is bit, as I already told you, if you don't understand system verilog, you will definitely not understand the universal verification methodology, because it is bit more difficult compared to that of system verilog, which is we call it as high learning curve. But if you are enthusiastic, you can do it, right? And the second disadvantage is that it is not big of a disadvantage. Basically, either system verilog or UVM, why is it developed? We are developing it for designing the complex test benches, is it or not, right? So when we are developing complex test benches, then the flow, since it was designed with certain guidelines which are for designing complex design test benches. So basically when we are just verifying a simple test bench, when we are just verifying simple test bench structures, we don't opt for UVM because it will be much more difficult. Okay, so in such cases, when we are just checking the verifying simple designs, then UVM, using UVM may be seeming as unnecessary because it is having many complicated code, so which may impact the performance of the basic code that you are developing in your TB, right? So the UVM class hierarchy is categorized into three types, which is UVM object, UVM transaction, and UVM component. So all the predefined and user defined classes that we are using in UVM are categorized into UVM components and UVM objects. So basically, whatever classes that you are using in order to build the code, all these are present in either UVM object or UVM component. So basically, that is why we will be considering these two, UVM object and UVM component, as a basic building blocks upon which we will be developing our entire UVM code, right? So this is the hierarchy. So basically, starting the main components are UVM object and UVM component, right? And then the UVM transaction also. We will be talking about what is this UVM object, what is this UVM component, and what is UVM transaction, what is the difference between UVM object and UVM component. So all these things we are going to discuss today, right? Now coming to the first one, which is UVM component. So this was introduced in the UVM, like UVM component was the introduced in UVM itself. You don't see this UVM component within the system verilog, UVM component and UVM objects, right? So these were introduced in universal verification methodology. So what is this UVM component? So simply put it in words, like in order to make you understand simply, the components are UVM components are nothing but those classes whose objects will be available from starting of simulation to the end of simulation. Like if we are considering the starting of simulation to the end of simulation as a life cycle of our TB. Okay, that means from starting to end, if we are considering it as the life cycle, so those components which are present in this entire life cycle are called as UVM components. For example, okay, in order to make it more easy to understand, like drivers, there are certain components like drivers, monitors, right? So these are components, etc. There are many, like scoreboard. If you see, these are certain components which we will be seeing from entire simulation, like from starting of our simulation to the end of simulation. We need these components, like we'll be using the drivers, component, monitors, like all the different teams will be using these components like drivers, monitors. So they will be present from starting of simulation to end of simulation. That means in the entire life cycle of TB, if there are certain components which are present in the entire life cycle, then all those components will be coming under this UVM component category. Got my point? So this is UVM component, right? So the objects of those classes, right, which are in the entire TB life cycle. Those are called as UVM components. Clear? Right? For example, drivers, monitors, etc. So, since these components will be present in the entire life cycle of our TB, so they need to follow the phase concept, right? So that means in system, in UVM, sorry, in UVM, the phasing concept was introduced. Like there are various phases in UVM, like build phase, connect phase, run phase. So in this way there are various phases. Don't worry about that, we'll be discussing it in the upcoming classes. So since the UVM components are those which are present in the entire simulation, entire life cycle of the TB, so they need to follow this phase concept also. That means they need to undergo various phases. All the UVM components will be undergoing various phases concept. Right, so this is about the UVM component. So UVM component is considered as an individual block of TB which will perform some certain specific task. Okay, for example, while driving the stimulus, it will be performing some tasks. While monitoring the stimulus, okay, these are certain tasks in order to drive some stimulus, in order to monitor some stimulus. So, all these are the works which are performed by the UVM components, right? So, this is about the UVM component. Clear? Right? So, now coming to what is UVM object? The entire opposite thing of UVM component, like what we have talked about UVM component, those components, like those classes of objects which are present in the entire life cycle of TB. That means which components are required from starting of simulation to end of simulation, those categories come under UVM components, right? So the opposite of that means those objects which are not required for the entire life cycle of TB. That means from starting to ending, if there are some components which are not required from starting to end of the simulation, then those components come under, sorry, those objects will be come under this UVM objects, right? Clear? So there are two categories, UVM component and UVM object. So the object of classes which will be present from entire life cycle of TB, they are categorized into UVM component, and those objects which are not required in the entire life cycle of TB, they will be categorized into UVM object, right? So examples of UVM components are like driver, monitor, so all those things. Okay, now coming to examples of UVM object. Okay, transaction class. Okay, you will be seeing the transaction, right? So the transaction class is something which is not required in the entire life cycle of TB, right? So this category, like this, the transaction class objects are will be coming under this UVM object, right? So there is one advantage of this UVM object. Since it doesn't need in the entire life cycle of the TB, it can be created anywhere and it can be destroyed anywhere also, right? Okay, whenever we require it, we can create it. Whenever we require it, we can just we don't require it, we can just destroy it, because there is no need to save it for the entire thing. Okay, so whenever we need it, we can create and we can destroy it whenever it is whenever the work is completed, right? So that is called UVM objects. Less those objects which can be created whenever we require and which can be destroyed, those come under UVM object. But those objects which should be required, which are mandatory for our entire life cycle, those come under the UVM component side, right? So this is the UVM component and UVM object, right? So the example of this UVM object is like transaction classes, and we have already just now we have discussed they don't need for the entire life cycle. Since they don't need the entire test bench life cycle, they don't need to follow any phases, they don't undergo any phases, like all the phases they don't undergo, right? Because they are not present from starting to the ending, they don't need to follow any phases, right? So this is about the UVM object. Now both this UVM object and UVM component. Like what is this UVM component and UVM object? They are nothing but classes, right? So classes needs to be, in order to make a particular, you already know what are classes in system verilog, right? Classes require objects, is it or not? So these objects needs to be created, right? So in system verilog, you will be, how you will be generating the package, like how you will be creating the object. You will be using the new function, is it or not? In order to create an object, you will be using a new function. But in UVM you don't use the new function. In UVM you will be using the factory. Okay, UVM factory, in order to generate the objects of these classes. Like in order to generate the object of transaction, in order to generate the object for a transaction class, for monitor class, for driver class, for all these classes, you will be generating the object with the help of UVM factory instead of new function. This new function you will be using in the system verilog, but in UVM you will just be using the UVM factory. There are many other advantages for UVM factory, we'll be discussing it further. Like, so all the, just like now we have discussed, all the classes objects are registered within the UVM factory, because UVM factory is responsible for generating the objects for these classes. So we need to register all the UVM components that we are using in order to develop our test bench in this UVM factory itself, right? So this is about the UVM component, UVM object, and then the UVM factory. Now let us see what is the difference between UVM component and UVM object. We have already discussed this. Like, UVM components are non-transient in nature. That means they don't have short period of time. Like transient means which are for short period of time. But UVM components are those components which need for the entire life cycle. That means they should have a long time period. So they are non-transient in nature. But when it comes to UVM objects, they can be created anywhere. They can be created when needed. They can be destroyed whenever it is not needed. That means their lifetime is short period of time. That is why UVM objects are transient in nature, whereas UVM components are non-transient in nature, right? So UVM components are static in nature because they exist through the entire simulation time. They are static in nature. But when it comes to UVM objects, they are dynamic in nature. Why they are dynamic in nature? As we already told you, that they can be created whenever we need. They can be destroyed whenever we don't need. So they are, this is nothing but the dynamicity, right? So the UVM objects are dynamic in nature and UVM components are static in nature, right? And then coming to, as we already discussed before, that both UVM components and UVM objects need to be registered in the UVM factory, right? So how are we going to register it? In UVM factory we are having macros like tick UVM component utils and tick UVM object utils. Okay, if you see here, whatever components that come under UVM component category, those should be registered with tick UVM component utils macro. Okay, whatever objects that will be coming under UVM object, those should be registered with tick UVM object utils macro. Okay, they shouldn't be mismatched. That means UVM components should be only registered with UVM component utils macro, and UVM object should be only registered with UVM object utils macro. Okay, UVM objects again, they shouldn't be mismatched. That means component should be um, should not be registered with UVM component utils, and object should not be registered with UVM component utils, right? So this is the difference between UVM component and UVM objects. Now coming to what is UVM transaction. So you already know the transaction is nothing but generating stimulus. Okay, so it is used in order to generate the stimulus and analyze it. UVM transaction will be used. Okay, and also as we already discussed, they are transient in nature. Why? Is because transient means they are only created whenever they are needed. Like whenever we need a transaction, it is generated, and then whenever we don't need it, we will just leave it, right? So that is UVM transaction. So whenever we are generating some simple transactions, they can be derived using UVM transaction class. Like they are, as we already know that there are three classes which are UVM component, UVM object, and UVM transactions, right? So whenever there are just simple transactions, we can derive it from UVM transaction. But if there are some specific classes, okay, some specific sequence specific transactions, then what we will do, we will be deriving such type of transactions with the help of UVM sequence item. In the previous session we have already discussed about what is this sequence item and why do we need this sequence item in UVM, right? If you didn't see that video, I'll link that in the description box. You can go there and check it out, which is the introduction of UVM, where I have discussed what are the UVM, what is UVM, what is the need of UVM, what are the various introductions that were done in UVM. So all those things you can just check it out in order to know what is this particular UVM sequence item, right? So if you want any some specific transaction, sequence specific transaction, then those sequence specific transactions will be derived from the UVM sequence item. If there is no any specific transaction, then if there are just simple transactions, they can be derived from the UVM transaction class, right? So this is about UVM object, UVM transaction, and UVM component, right? So in the next session we will be talking about many more concepts like UVM architecture and all. So don't miss the sessions. And if you like this video, please do like it and also share it to all the VLS aspirants who also want to enter into design and verification domain. And also please do give it a like so that it is kind of motivation for me to make more such videos on UVM. That is all for today. Thank you all.